In this lesson, I'm going to talk about horizontal and oblique asymptotes. So horizontal is pretty self-explanatory. A horizontal asymptote is a horizontal line that a graph reaches but never touches. And oblique asymptotes, it's not completely horizontal. Another name for an oblique asymptote is slanted. So it has a slope. Okay, so to predict if a function has a horizontal or oblique asymptote, I have made up a slide here to help you remember a few things. So starting with the first sentence up here, it says the graph of a rational function y is equal to f of x over g of x, where f of x and g of x have no common factors. So we're talking about rational functions where it's been factored and therefore there are no common factors. So that's really important. These four scenarios don't work unless it's already factored. So let's look at the first scenario here. If we have a degree, if the degree of f of x is less than the degree of g of x, in other words, the numerator has the degree less than the denominator, then we have a horizontal asymptote right at the x-axis, y is equal to 0. So to look at this behavior, I want you to go into your graphing calculator and actually plug in a rational function with this characteristic. So an example of a rational function would be x over x squared. So notice that the degree of the numerator, which is 1, is less than the degree of the denominator, which is 2. So if I plug in this function into the calculator, let's observe the graph. So x over x squared, we'll try a zoom 6 standard for now, and we have a rational function graph. So notice that there is a horizontal asymptote, and that's located right along the x-axis. So that is the line that the graph approaches, but it doesn't touch. Okay, so that's the first scenario. We're going to go to the second scenario here where the degree of the numerator, so f of x, is equal to the degree of the denominator. So the numerator and the denominator have the same degree. When this happens, there's a horizontal asymptote at y is equal to a over b, where a is the leading coefficient of f of x, and b is the leading coefficient of g of x. That's quite a bit of information here. Let's actually observe a graph with these characteristics. So I'm going to pick y is equal to a rational function, so 2x cubed minus 4 over x cubed plus 4. So the reason why I'm picking this function to describe this scenario, notice that the degree of the numerator and the denominator are the same, so a degree of 3. Also, the leading coefficient of the top is 2. The leading coefficient of the bottom is 1. So in theory, if this is a valid statement here, we should have a horizontal asymptote at y is equal to 2 over 1, which gives me just 2. So to observe this behavior, go back into your calculator. We're going to plug in this function. So y equals, clear anything you had in there before. You're going to go 2x cubed minus 1. Oh, I'm sorry. Put brackets around your numerator so that your calculator does not get confused. So I'm going to go back and put brackets in there. So second insert bracket. And you're going to divide by x cubed over, just get my calculator just 1 second here, divide by brackets x cubed plus 4. So try zoom 6 standard and let's take a look at the graph. So we have a rational function and we have a horizontal asymptote. So there is a horizontal line that this graph never reaches or approaches it, but it doesn't touch it. And that line is right there. So it goes right through 2. So therefore we have a horizontal asymptote right at y is equal to 2. So that graph will not touch this line. Okay, so moving on, we're going to go to the third scenario here. The third scenario is when the degree of f of x plus 1 is equal to the degree of g of x. So this equation means the degree of f of x is 1 greater than the degree of g of x. So an example of this type of function would be y is equal to x squared plus 1 over x. So notice the degree of the top is 2, and it's 1 greater than the denominator, which has a degree of 1. So if this happens, we have an oblique or slant asymptote. So looking at the graph, I'll show you what an oblique asymptote looks like. Clear whatever you had in there before, go to your y equals, and you're going to plug in. Okay, so brackets x squared plus 1 over x. So try zoom 6 and notice what happens to the graph now. The graph has a slanted asymptote, and as you can see, it's not going to touch this slanted asymptote right there. So it's not a horizontal asymptote, it's what we call an oblique or slant asymptote. And that occurs when the degree of the denominator is 1 more than the degree of the denominator. Okay, so to our fourth and last scenario here, when the degree of f of x is greater than g of x, there are no horizontal asymptotes. So if it's greater than g of x, or the numerator is greater than the denominator, that means there are no horizontal asymptotes. So it's not greater by 1, it's greater by a lot. So there is going to be no horizontal asymptotes in that case. So an example of this type of function is y is equal to x cubed plus 1 over x. So the degree of the top is bigger than the degree of the bottom, hence we have no horizontal asymptotes. So go back into your calculator here and I'll show you what that looks like. Y is equal to, clear, x cubed, there you go, plus 1 over x. So try zoom 6 standard and take a look at the graph now. Do we have any horizontal asymptotes? We don't have a horizontal asymptote, hence this fourth scenario is valid. So those are the 4 different scenarios of a rational function when it comes to horizontal and oblique asymptotes. Just one thing I'm going to stress before I close this lesson is that you have to make sure before you apply any of these scenarios that your function has no common factors, so it's fully factored. So that's my little introduction to horizontal and slant asymptotes.